So this question is copy list with random pointer. So you are given the linked list, and there's a next and random pointer that you need to store in the single node. So what you need to return is you want to return a copied linked list, not the original one. And then in the copy this node, you cannot point at the original node. So this question is pretty tough, and then um, bear with me. So this is the original node, right? So we need to create a copy. Let's point at the copy 13. Let's point at copy 11. Point at copy 10. Point at copy 1. Point at copy node. So every single pointer that point at the copy node, not the original node. So I'm not going to lie. This question I learned from someone in the post. So you're going to have to create uh, like a pointer from here. So this is going to be 7 original. Then you will create a copy for 7. This is going to be pointed next, right? And then this will be the 13. 13 with original, and then 13 with next. And then continue. So 11, 10, 11. 11 with original, 11 with copy, 10 with original, 10 with copy, and the last is going to be 1 original and a 1 copy, and then a no, right? So no for original, and then no for copy. All right. So this is like 1D linked list, right? Like the original one, like you think about. So in this original node, maybe I need to zoom out a little bit. In this original node, there is a random pointer. So the random pointer for this one is going to be point at no. So as this is like next. Hold on. Next. This is going to be next. This is going to be next. 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 And then there's a pointer that's called random. Random. And technically you want to find out like how do you traverse every single node, and then also copy with a random pointer. So again, like we can construct this big diagram first, and then what we can do is when we traverse from the head again. So once we have this is pretty good so far for the first iteration. And then once we have this, we want to find out what is the next random, right? So in this one, I know my copy is 7. I know my copy is going to be, the 7 original copy is going to be 7 copies right here. It's going to be a next pointer. So what I should do is I want to say, I want to store my copy or my random. I want to store my random copy, you know, for this node. So I can do this. I want to find 7, the original 7 random first, and I want to find out the next, right? So 7 random is no. This is original node, but I want to have the no copy. So this is original random dot next, right? And then what you should get assigned is going to be assigned to this one, right? You want to say original dot next dot random to this. So this kind of pretty tricky. So you want to find out what your original node random, and then once you find out the random is going to be the original node, you want to find out the next for it. So once this happens, you already store every single you have every single random node for the copy node. Okay. So the next is going to be since the original pointer next is point at every single copy, right? We don't want it. We want to point, so none of the pointer in the new list should point at the original list, right? So we want to make sure the original still point at original, and then the copy will point at the copy, right? This is the idea. And then what we should do is we need to create a copy. I mean, copy head something like this, right? And then we copy iterate anything. Now we need to keep point at whatever we have, like every single iteration, and then based on that, we need to do this. So we need to cut off the windows like this. So what does that mean? If I have these windows, I know my original head is valid. I know my original .next is also valid because it's a copy. And then I want to make sure, do I have a next? If I do, right, which is going to be original .next. If I do, then I'm going to change my current pointer from here to here. So I'm doing like two at a time. I'm doing like two windows at a time. But before I do two windows at a time, I want to know my my next is available. So I will be able to move um, safely, right? Because if this is no, and now I'm trying to make sure my copy .next is valid, which is not going to be valid, right? So if this is no, I want to know I can, I can stop at right this moment. So this will be the entire solution. I mean, it's a little bit uh, challenge challenge for sure. So what I can do, I'm going to say current is equal to head for now, and I'm going to have a copy. No, it's not copy right here. So I'm going to have a next, and I don't need to assign anything. So what I can do is I want to say if the current does not know, and I store my next is equal to the current dot next, and then once I have the next, I know how to shift, right? So I would say current dot next is equal to something, right? And then my current is equal to next. So in this first iteration, I'm not going to draw a diagram again. In this first iteration, imagine this is node 1, this is node 2. And the current on next original is like this. But what I need to do is I want to create a copy node. And I want to change this pointer to here. And then change the copy node to here. So I need to have a copy node right here. Create a value for this one. And I want to point at the copy node next to this one. I want to point at the current next to this one. So yeah, I just said it, right? So it's going to be copy node is equal to new node. It's going to be current value, and then copy node next will become the next, and then current next will be the copy node, right? So it's going to be something. So this is the first iteration. I just create. It's going to be first iteration. Original first one, copy first one, original second one, copy second one, and so on. So this is a linked list right now. And what I need to do is I want to make sure my render is valid, right? So the render, the original node have render, but copy node does not have it, right? I only store the current value and also point at the next, right? So I want to do the same thing. So current current is equal to the head again. So current does not equal to no, and then in this iteration, I want to make sure I have the next available. So it's going to be current next. So and then I will just update my current equal to next at the end. So in this one, I'm keeping the valid original node for the for the next, right? And then I update my current node. So again, I need to assign the random, right? So, well, if current dot random does not equal to null, then I will just say current dot next dot random is equal to the current dot random dot next. So I still have to draw like what's this happening. So this is original one, and this is copy one. So I'm gonna say hold on. So I have an original 2. Maybe I need to draw it again. So original 1 point at copy 1, original 2 point at copy 2. Alright, so this is current moment. So what I need to do is I want to check, does my current random has something? It has to be something, right? Because this is the original, right? So I'm going to point at the next. So this is the next. The next dot random. So this next dot random, the pointer, it has to be the original node dot next. I mean the original random dot next, right? Because I have the original. Original is going to be pointed at some original value, right? But this original value has a copy, right? You want to point at your copy random into the copy node, not the original node. So it has to be random. So it has to be a current dot random. So imagine this is a random, and then you point at the copy node, which is dot next. So this is how it is. All right. The next is going to be you want to point at whatever the copy, the original node to original node, and a copy node to a copy node. So in this one, I'm using a dummy head is equal to new dummy, new node equal to 0, and then I'm gonna have a copy current. I mean, since I'm using the current, I'm just using the copy current is equal to dummy dot head, and then I have a copy. Copy is something that I don't want to touch anymore. I'm going to assign and then keep reusing, and then the current copy is just like what we are doing, traverse based on this. So again, we need to create a current back to the head, and then while the current does not equal to null. Alright, anyway, so while current does not equal to null, right? At some moment of time, I will break out this. And then what I need to do is I want to point my return value, which is a null, which is going to be the copy. Okay, return the head of the copy, right? Copy linked list. So I'm going to say dummy.next. So this is the return. Okay, so yeah, I should draw again. So the first thing is this is original 1, copy 1, and then original 2, copy 2. And then again, you need to like cut off the windows like this, right? So you want to make sure your next.next is valid, right? So if it's not valid, then you don't need to keep traversing. And then, but again, like, let's see, where is it? So this is original node and then copy node. And then what we should do is we have copy current. The copy current is pointed at the dummy right here. So I have a dummy here. Copy current right here. I point at here, right? And then I have a copy. So copy I have by default is going to be empty. So this is actually pretty safe because I want to make sure my copy current is something. Then I will assign the current node into the copy. All right. So again, you're going to do this. So you want to store the next. So this is going to be next, and then the current copy will become the current. So this is current, right? This is current. Current.next. So my copy is this, right? My copy is this, and then my copy.current was initially so this is not pointed. This is equal, right? This is equal to each other. So my copy.current will point. the next will point at copy, right? So I'm using this copy current to traverse. So I'll point at the copy, and then once I point at the copy, I assign my copy current equal to copy. And once that happens, I know my copy is not moving. The thing is moving is copy current. So I'm just keep changing my windows, and then my current copy will keep updating, right? And again, the pointer will keep updating as well. But once that happening, like this will point at here, this will point at here. So this is a trick. So I'm gonna do this. So next is to go to current.next, and then at some moment of time, you want to say current equal to next for sure. And then current.next, so current.next, so current.next will become the next, yes, current.next. Current.next will become the next. So you want to, so this is going to be original one, this is going to be copy one, this is going to be original two. So you want to do current.next equal to next, and you want to reset your pointer to here, right? So I haven't touched the copy, so copy will become the current.next. This is without question. We know the copy node is after the current.next, right? After the current node. So, and then I'm going to say current.copy next is equal to copy. So I'm assigning the value, and then once that I assign, I just update my current copy, because this is the last valid copy node I traverse. So once I using this idea, my copy is getting updated before I get assigned it. So this is a trick. And then once this happens, it should be good. Oh yes. Okay, so for the time and space, space is actually all of them. You need to create the copy node. For the linked list, so it's all of them. For the time, it's definitely all of them. You need to traverse. It's actually 2n, but doesn't matter. 2 is constant, so it's just all of them. And then this is a solution for the linked list that you traverse, and it's pretty difficult. And if you understand this, your linked list is pretty good. All right, so the next solution is going to using the map. So this solution is simpler, but it's not, not a good idea to write in the code like this. So, but again, I'm going to tell you what to do. So, you have the original node. You already have the original node, right? You traverse the original node. While you're traversing, you create a map. So the key is store the original node, and then the value is, so the key and value, right, for the map, right? So value is going to store the copy node, and once you know your original .next, you literally just assign the copy.next, or original.random, you assign copy.random. This is straightforward. The hash map, no map equal to new hash map, and then I traverse. So for no equal to head, and no does not equal to no, and then no equal to no.next. So I iterated from temp no. I'm not changing any head. So I'm just adding a current value. So it's gonna be no, and then this is gonna be an original no, right? And I'm gonna have a copy no, new no.val, and then this is copy the original node, but I still need to assign my next and random, right? So you need to do the traversal again. So you want to assign your copy node, right? You want to assign your copy node, so it has to be get your node dot next, and also that get a node dot random, right? So this traversal is assign your copy next and random, right? So it's going to be map.get, map.get next, and get random, right? So how do you get the next from your original node? And your original node is going to be map.get original.next, right? And then it's equal to map.get original.random. So this is how you get the copy node, right? And after that, you just have to return your copy head. So your copy head will become map.get head. So this was literally everything. So you might be wondering like, oh, this is original, right? But technically, when you're doing the get, you are actually, point at the copy node. So it's not technically point at the original. It's actually point at the copy node. But what's the copy node? It depending on your current node. So node.next, imagine 13 or 7, 7.next, right? You actually point at the 7 copy next, not the original 7. So this is a trick. So time and space is the same, all of n for the time and all of n for the space. So this will be the solution. All right. See you.